Welcome to a lesson with Dr. Powell. Let's take a look at an example of a related rates problem. Let's suppose that the radius of a sphere is changing. It looks like it's decreasing here. So the rate of -5 meters per second. And at this particular moment in time, the radius is 8 meters. Okay, this is just instantaneously, so it's changing very rapidly, instantaneously, right at this moment. But we want to know how fast is the volume changing instantaneously at this particular moment. So we need an equation that relates the variable v and r together, but thought of as functions. Volume is a function of time, r is a function of time. We're taking derivatives, aren't we, of them? Okay, so if we have an equation that relates v and r as functions together, a function equivalence equation, then that equation is an equation of two functions. Two functions are the same. The derivative of this both sides would then be the same, because if two functions are the same, their derivatives are also the same. Okay, so, but keep in mind, remember, we don't plug in any values. We keep these things variable, r and v, until after we have our derivative equation. All right, so first, how do you relate v and r together with a sphere? We have that the volume of a sphere is 4/3 pi r cubed. There it is. Really, our formula for volume of the sphere gives us a relationship between the function v and the function r. Take a derivative of this equation with respect to t, or of these parts, where this is a function, that's a function. So the derivative of v is dv dt, and this part right here, 4/3 pi is just a constant, 4/3 pi, and then the derivative of r cubed using the power rule and chain rule, 3r squared times dr dt, where r is a chunk, it's a function, so if we're cubing, we need to use a chain rule to multiply the derivative by the derivative of the inside, which is dr dt. Okay, so now notice 3's cancel, and at this moment in time, r is 8. So we can plug things in now. 4 pi times 8 squared times dr dt, which we know, it's -5. And I'll forgo on the units here, and we can just get the units to the end. -5, and dv dt is what we're looking for. Oh, look, we have it right here. Okay, so, all right, so we have 8 squared is 64, 4 times 5 is 20, of course there'll be a negative. So doubling 64 is 128, and then multiplying by 10, because multiplying by 20 is doubling and multiplying by 10. So -128.0 pi, and units would be, since it's meters, be cubic meters per second. That's a pretty fast rate. So the radius is going down that fast, which is really fast. The volume is actually going down at that rate instantaneously. That's quite a bit right there when you think about it. With a big radius anyway, the volume is pretty big in terms of cubic meters, because you have 4/3 of 8 cubed and then times pi. That's getting pretty big. Okay, so so that would be it there. We just computed it, and we'll end there. Thanks for watching.